Okay, so for this, the elevator problem is because the elevator problem, you see that elevator problem has how many variables? Elevator problem has two variables, M1 and M2. Okay, so the M1 is, you see that M1 is 1200 and M2 is 920. Okay, we have two variables and the variables are numeric. So then we have to use number and double, because we want, our answer was more than 2 decimal number. See, you see that the answer is how many decimal? 1, 2, 3. So that's why we must use this one, double. Okay, so let's use double. So the double, so double is the variable and the
Dream to land on the moon or colonize Mars? Learn coding. This semester, Rashidul Bari is teaching C++ at City University of New York. Watch his lectures to achieve your dream.
Today we're going to do Etrid machine, two mass hanging on a pulley, as simple as that. So let's draw a pulley and put two mass that hanging on this pulley. This is mass number 2 and this one is mass number, and this one is mass number 1. Okay, so this is called Etrid machine. Or sometimes it calls elevator problem. Alright, so in the United States, it is illegal to have acceleration greater than 1.2 meter per second every second in the elevator. So if the acceleration inside the elevator is more than 1.2 second every second, then the elevator gets shut down and repairmen get called and elevator get repaired. So if the acceleration must be less than or equal to 1.2 meter per second every second, otherwise elevator get shut down. But why you did do that? You don't want to take the elevator that accelerate 9.8 meter per second every second, then you're going to be in free fall, then you're going to die. Even 7 meter per second every second, even 5 meter per second. I know a story when elevator accelerate 5 meter per second every second and people die. Just too much. So elevator acceleration must be less than or equal to 1.2 meter per second every second. The elevator we have is the mass 1 is 1200 kilogram and mass 2 is 920 kilogram. We want to see that whether this elevator is, whether the acceleration in this elevator is smaller than 1.2 or bigger than 1.2. If it is bigger than 1.2, then we'll shut it down. Okay, now few things. First we have to do force diagram. Just to remind you, we're going to solve this problem using C++ at the end. So we're going to solve this problem using C++ at the end. First we're going to use the physics. Okay, so first we're going to draw a force diagram. So I'm going to draw the force diagram right here. Mass 1, I'm going to color differently. Mass 1 is green and mass 2 is blue. So this is mass 1 and this is mass 2. Mass 2 and this is mass 1. All right. So what we are doing? We are doing a force diagram. So what force is acting on this? The elevator is, there is an acceleration. This is the heavier, so elevator is accelerating this way. We are looking at the system as a whole. All right. So the acceleration is, this part acceleration is upward, and this part acceleration is downward. Very important, very important. What other thing do you see? This is M2G, this is FT. FT means tension force. The tension is acting on the rope. Tension is a force that acting on the rope. Force is a push or pull. The tension force is only a pulling force. Can you push something using a rope? You cannot push anything using a rope. So the tension force only a pulling force, because you cannot push anything by using a rope. So keep that in mind. So this is the force diagram for mass 2. Then we're going to draw the force diagram for mass 1. All right, mass 1 you have M1G FT. All right, that's it. Now we're gonna write the same thing again. So you see it twice and you understand it, because students often do not understand the Attwood machine. So I'm gonna write M2G. I'm gonna write FT. Okay. And I'm gonna write acceleration up. I'm gonna write M1G. I'm gonna write FT, and I'm gonna write acceleration down here. Acceleration up means positive A, acceleration down means negative A. Keep that in mind. Now we're gonna write the equation in terms of Newton's second law. You know that Newton's second law is the most famous law in the universe, along with Einstein equal mc squared. So we're gonna use Newton's second law. So Newton's second law tells us that F equal ma. Now what direction? At the y direction. All the forces acting at the y direction. There is no forces acting at the x direction. No one is pushing the counterweight from the x direction. So we're gonna write y here. We are not writing any y for m, because m is a scalar quantity. M has no direction. So y direction, we're gonna make y fy red, because we're gonna replace that by ft minus m2g. Okay, all the forces at the y direction we replace is equal to ma. And by the way, this is m2a. All right, so, and is this a positive a? Yes. So you're gonna write a positive sign here. Okay, so this is the equation for this one. Now you're gonna write the equation for this one. Again with Newton's second law. F equal ma. Again at that y direction. So again I'm gonna make it red, because I'm gonna replace this Fy by this and this force. This is Ft minus M1G is equal to M negative A. So I'm going to put negative over here. This is M1, so I write M1. So we have now two equations. All right, so you're going to put one equation on top of other. Okay, so let's first put this equation. Ft minus M1G is equal to minus M1A, and then put this one. Ft minus M2G plus M2A. Now we cannot do anything, because how many variables over here? We have Ft is a variables. M1 is a variable, But we already know M1. M2 is we already know M2. A is a variable. So we have two unknowns. When you have two unknowns, you must use system of equation to cancel, to get rid of one unknown. So we cannot get rid of A because that's what we are finding. We are trying to find the acceleration because we are trying to see whether this elevator moves faster than 1.2 meter per second every second. Now let's come back over here. We have to get rid of one unknown. So, and that unknown is Ft. How can we get rid of Ft? We have to multiply this one by negative. If we multiply this one by negative and this one by positive, what happened? What happened? We get, that's what we get. Negative Ft, positive M1g, positive is equal to positive M1a. Okay, so I multiply by negative across. Now I'm going to multiply it by positive. So now Ft minus M2g is equal to M2a. M2a. All right, now I'm going to canceling these two. Now I have M1g minus M2g is equal to M1a plus M2a. All right, now I'm going to factor out g over here. Okay, so I'm going to factor out g. So M1 plus minus M2, and I'm going to factor out a, M1 plus M2. So acceleration is M1 plus M2, M1 minus M2 times g. This is g. All right, now we're going to come over here. Now we're going to plug in the values. So we have M1 is 1200 minus M2 is 920, M1 is 1200, M2 is 920, divide by multiply by 9.8. So now I'm going to take a calculator and let's see what happened. So 1200 minus 920 is 280. 1200 plus 920 is 2120 times 9.8. So 280 divided by 2120 is 0.13 times 9.8. Voila! It gives you 1.294. So it gives you 1.294 meter per second squared. So this elevator is bad. This elevator is no good. This elevator accelerates too much. This elevator has to be shut down because it moves faster than the law requires. Okay. Now what are we going to do? We're going to write the code. Okay. So let's write the code for this problem. Okay, so I'm going to write the code over here. So C++ code for elevator problem. All right, so let's write the initial code first. So we're going to write include IO stream. Okay, that include IO stream. I don't think you see this color, so I'm gonna keep using the black. I forgot to use black before. Not sure whether you saw the other thing better, but now I'm gonna use the black. So using, oh, this doesn't work. Let me change something. Alright, so using namespace std, okay, then we're gonna write int main. Int main is the function, so this takes you, this gives you access to the library. This one allow you to not to keep writing std in every single line of the code, and this one is the function. So you're gonna have one function for this code, and the function is always the body is always in the curly braces. All right, so let's talk about the data type before I finish this. Let's talk about the data type. So the data type, there are three types of data type in computer science. The first one we're going to say language. The second one we're going to say number. And the third one we're going to say boolean. And the first one is divided in two parts. Card means characteristics. Second one is string. The string means I'll give you example in a second. Let me first write them. Number, we're going to divide it in three parts. The first one we're going to say int. Int means a whole number. Float is number with 2 decimals, and then double. And then boolean, we use both. Okay, the examples now. For the card, it's just one letter, and we use only one quotation. For string, more than one letter, we use the double quotation. Int is a whole number. So for example, 5. For int, we do not use the single quotation or double quotation, we use the semicolon. For float is a number with 2 decimals, so 1/4, for example. Because 1/4 give you 0.25. Double more than any decimal you want, for example, pi. So because pi is 3.14159 and continue go over forever. Boolean is there are two, it's like a binary, it's yes or no. Okay, so for this, the elevator problem is because the elevator problem, you see that elevator problem has how many variables? Elevator problem has 2 variables, M1 and M2. Okay, so the M1 is, you see that M1 is 1200 and M2 is 920. Okay, we have 2 variables and the variables are numeric, so then we have to use number and double, because we want, our answer was more than 2 decimal number. See, you see that the answer is how many decimal? 1, 2, 3. So that's why we must use this one, double. Okay, so let's use double. Double, and let's call M1. Why we call M1? Because this is our M1. M1 is equal to 0. Double, M2 is equal to 0. All right. Now what can we do? Now we're gonna have to write count, print statement. We're gonna tell the computer, we're gonna give the computer input, and this is how you give the computer input. Count less than, enter M1, less than, and L. And L means end line. Then you're gonna write scene, because you want to give computer an input. But computer wouldn't know that you gave input. You have to tell computer, suck it up, take the input from the console. So then computer take the input from the console. So you're gonna write scene, and then you're gonna write M1 and semicolon. All right, so far so good. Okay, now we're gonna write it for M2. We're done with M1. Now you're gonna have to write it for M2, you see? So let's write it for M2. So count, enter, M2, and L, okay? Scene, M2, all right? Okay, so we're done with M1 and M2. Okay, now what are you gonna have to do? You're gonna have to write this equation. What equation do you have to write? This equation. A is equal to M1 minus M2 over M2, M1 plus M2 times G. So that's what we're gonna do now. So you're gonna write double acceleration is equal to 9.8 times parenthesis M1 minus M2. So we have M1 minus M2. Hope you remember that, M1 minus M2. And then we're gonna write over M1 plus M2. So we're gonna write over M1 plus M2. Okay, so that's M1 plus M2. And then curly braces, semicolon, and then we're gonna have to write a French statement. So count, you're gonna write acceleration of this elevator is, and then we're gonna write A. So this A right here. So you're gonna write this A. And now we're ready to run. If we run this, then the acceleration, the computer will gonna give you acceleration exactly same thing you did it by hand, 1.294. 1.294. Now let's see, now that we increase we have the big font size. Now let's see how big it is. Is it big enough for you to see? So hashtag include hashtag include IO stream, IOSTREAM. So include IO stream. So I'm done with the first line. Now I'm going to write the second line using a namespace std. Now I need a semicolon. Hopefully this guy has a semicolon. Thank God it has semicolon. Now I'm going to write the function now, int main. Int, okay, I'm done with int, and then I'm going to write main. Int main, and I'm going to write the parenthesis. Hopefully this guy has a parenthesis. Thank God it does. Okay, now I'm going to write the curly braces. Hopefully this one has curly braces. Okay, so what are we going to write first? We're going to write, as I told you, we're going to write the data type. So we're going to use double. So the double. So double is the variable, and the name of the variable is M1. M1 is equal to, we're going to initialize it to 0 as always. And then double M2. M2 is for the mass 2 of the elevator. The elevator has two mass, two unknown. One is mass 1, 1200 kilogram, and other one is mass 2, 920 kilogram. So we have to put that so that later on, when we are ready, we can tell the computer that mass 1 is 1200 and mass 2 is 920. So we're done with this one. Now we have to tell computer that take the information from me. So the computer gonna take the information for me in this way. So we're gonna have to write count count less than, now we're gonna do less than, and then we're gonna write the quotation mark. Hopefully we have the quotation mark. This is all right, I saw the quotation mark. Okay, so I'm gonna write enter. So enter M1. M1 means it tells the computer, all right, ask for M1, and then user will give M1. All right. So then I'm done with this. So I'm going to leave some space, and I'm going to put a colon, and make sure I have everything right here, colon and everything right here, and then I'm going to put less than again. So less than. All right. So I'm going to write endl. Endl means end line. Okay, I'm going to write endl. So I'm going to put the semicolon again. I'm looking for the semicolon. So you see that now I have almost done. Now I'm going to on the computer, if you put this console, you're going to put this is called console. You're going to put the input on the console. So once you put the input on the console, the computer has to suck it up. So then you're going to write a code that tells computer, go suck it up. Sin greater than, and then we're gonna write M1, and then semicolon. All right. So now I'm gonna write the count again, and this time count for M2. So I'm gonna write count, and then I'm gonna write less than, and then I'm gonna write a semicolon, of course. Semicolon. So let's go right to semicolon. Where is the semicolon? Semicolon is right here. No, I'm not gonna write semicolon. Yeah, I'm gonna write double quotation. In the double quotation, I'm gonna write enter M2. Enter M2. So once I write enter M2, and then I put the colon, and then I'm done, and then I'm going to write less than again, less than, and I'm going to write endl. All right, so now, and what did I do wrong? Count, enter M2, and no, nothing wrong. All right, so now I'm going to have to write scene for M2. So scene greater than, I'm going to write M2. So M2. Lots of hard work here. So M2. So now I'm going to write the equation that A equal to G M1 minus M2 over M plus M2. So elevator formula. So you're going to write elevator formula. So we make sure we write double, and then we want to find the acceleration of the elevator, so you're going to better write acceleration, and then we have to write the equal sign, and then we're going to write 9.8 because acceleration due to gravity is 9.8. Hopefully this is point, guys. 9.8, and then we're going to write parentheses, and then we're going to write M1 minus M2, M1 minus, we're going to write you're going to write 2, M2, and then of course you're going to write divide sign, and then of course parentheses again, then M1 plus M2, M1 plus looking for plus sign, plus M2. Okay, so once we have that, we must have a semicolon at the end. So this is the formula. There is something missing, I know, that's multiplication sign. What did I do wrong? So I'm going to put it up. What did I do? I took that off. Okay. Now I'm ready to write the final statement, and that is count. So now I'm going to write count. Count less than, and I'm going to write elevator acceleration is elevator acceleration is and then I'm going to leave some space, and I'm going to put a colon, and I'm going to put less than, and then I'm going to finally write, oh, I have to put a quotation. Don't forget your quotation because this is a string. So quotation, quotation, and then I'm going to write this little a over here. So a. Alright, so I'm going to write less than, so less than, and I'm going to finally write and then I'm going to write semicolon, and I'm done. So now we're going to run it. So let's see what happens. You can write one more line, but you don't have to. Return 0. Return 0. Return 0 semicolon. Okay. Alright, the return 0 semicolon means I'm done with the coding. Now we're gonna run it. So let's run it. Let's see what happens. Run. Yep. It says enter M1. So M1 is 1200. Alright, now I'm gonna put enter. And M2, voila. M2 is what? M2 is 920. 920. Alright, now the computer has the input. Now remember, I wrote sin. Now if I put the enter, computer will suck up this, and computer will gonna use this a equal to. Computer will use this a equal to m1 minus m2 over m1 plus m2 times g to give me the acceleration. So let's do that. Elevator acceleration is 1.29434. This is a magic, guys. So hopefully you understood it. Hopefully you fall in love with computer science. But most importantly, hopefully you fall in love with physics, because physics is everything. Physics can give you the power of God.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.